the purpose of this video is for you to check your prep questions. And this is a really important step because in your free choice project, these prep questions, that's what you show you know. And your job next after you check these is to think about, what can I make to show Mrs. Fickus that I have not just a basic understanding, but a deep understanding of these concepts? So it's important that you have these right and use it like a checklist as you're developing your project. Remember that your test was not retakeable, but if this is not perfect, it is revisable. So you should be working towards getting straight fours on this project eventually, if not the first time, but hopefully the first time. Okay, here we go. The first thing you're showing you know, prep question 1 about standard number 11 for our year is, what is a tectonic plate and what do they float on? So the two underlined words are the most important. A plate is solid lithosphere and it floats on the jelly-like asthenosphere. Lithosphere is almost like saying crust, but it includes the upper part of the mantle. So I'm scoring to see that that's incorporated into your project. Next up, what happened during continental drift? I'm fine with these two words, that Pangea split. Now, evidence. It's up to you. You only need to incorporate 2. Tropical fossils in cold places, that's weird. Remember, Greenland, way up north, has tropical fossils? Well, that makes sense if Greenland hasn't always been where it currently is. This is also evidence. Same fossils on different continents. How did they get across the ocean and die? Well, the answer is they didn't. They died and were fossilized when continents were connected in the supercontinent Pangea. And then when Pangea split, that's what separated them. Erosion marks called glacial grooves, they actually match on separate continents. That is evidence that the continents were once together, and also the perfect fit of the continents. Another way to say that is the coastlines match. Sometimes students will say, what about rock types matching across continents? That's also good evidence. So you're just picking 2 there. Now, this gets, I think, honestly, a little bit tougher. This takes quite a bit of explanation. Alfred Wegener had evidence that Pangea split. He could not explain how. This is the how. You must have magma in there. Magma comes out at the mid-ocean ridge as the plates pull away. Now be careful, I want that in there. Remember, the place we traveled was Iceland that had this situation. Now, once the magma's out, you have to add this part. The magma cools into new crust, and then instead of just covering the old, it behaves more like a chisel and pushes the old oceanic crust away to move the continents. So that's what happens during seafloor spreading. Okay, now this one is standard number 14 for a year, and this one is honestly pretty simple to incorporate. Scientists said there are 3 boundaries: push, pull, and slide, but you do need to be using in your project the fancy words. So convergent is the scientific term for push, divergent pull, and transform slide. Now, standard 15 here is the results of plate motion. So at a transform boundary, we get earthquakes. That's like California. Why is that? Because the plates are sliding by, causing cracks in the crust called fault lines. So I need to see that that's incorporated into your project. So let's say you're doing a newspaper article or a newspaper. You would have news events that would incorporate this. Excuse me. Now, a divergent boundary, the result is seafloor spreading. This is like Iceland, and the plates are pulling away, and that's what allows magma to escape. Now, our 2 convergent boundaries, you do have to be careful here. It depends on what kind of crust is hitting. I honestly simplified and abbreviated a bit, but that's supposed to be continental convergent. So when 2 plates hit and they're both continental crust, there's the same density hitting, and you get mountain building. This is like Nepal, where Mount Everest, the tallest mountain in the world, is. And again, it's because you have the same crust type hitting, so nothing sinks. But in Japan, it was a totally different story. There, it's still convergent, but continental is hitting oceanic. So we call that a continental/oceanic convergent. And there we get volcanoes, Mount Fuji style explosive eruptions. Now, why is this? When the continental hits the oceanic crust is more dense. It's made of native elements, not silicate minerals. So it sinks at the subduction zone. And I know that sounds silly, but remember, I always say it's like it sings a song. It's getting hot in here. I'm turning into magma. You get magma at the surface, and that's the recipe for an explosive eruption. Okay, so use this to help you to incorporate everything into your project. Just get in touch with me if you have any questions on how to complete your project, or if you want me to look at it and see if, grade it kind of early and see if I see anything that's missing or needs